Good morning, everyone. So today we are going to see the numerical based upon the unit number two. Okay. So particularly we saw the different tariff methods in the previous lectures. What are the different tariff methods, and by using those tariff methods, we can calculate the energy cost. Okay. So in that energy cost, we have to consider three main different variables. The first two variables and three constants. That is the first variable, that is maximum demand in kilowatt, the Y, which is energy, total energy consumed by the consumer. Now, the maximum demand is a different one, and the total consumption is a different one. Okay. Consider there are different machines which are installed in one particular industry. If all the machines are started simultaneously at that particular time period, then the requirement at that particular point when all the machines are connected or the on, in that case, that will be the maximum demand. Okay, whatever the demand is there, that will be the maximum demand because all the machines, all the devices are on, switched on at that particular time instant. Okay, so at that particular time instant, it will require maximum demand. So if you consider there is an industry will require, or the maximum demand of industry is very high whenever we compare to the residential, because in industries there are heavy machines are available. So for generating the rating of those heavy machines are very high. So in that case, the maximum demand requirement of that particular industry is very high. Whereas when we will compare it to the residential building, the maximum demand of the residential building, any particular residential area, is less than the industrial area, right? So we can, or this particular cost of energy will be calculated based upon the maximum demand and also based upon the total energy consumed. Sometimes we just use the maximum demand, that is in first tariff method where the flat demand rate is there, flat demand rate method is there, where we have only considering the maximum demand, whereas in straight line method or the block meter rate method or all other methods, we are also considering the total energy consumed by the consumer. Also, if you saw the Doherty rate or three-part tariff, in which we have to consider the maximum demand, the total energy consumed, and also one particularly constant amount which is charged to that particular consumer during each billing period. So generally, whatever the tariff method which we use in India, it is this one Doherty rate or three-part tariff method. Okay, one screenshot. I will also share one peak of electricity bill which is distributed by the Mahavitran. So you can see there is some rates are mentioned in which the constant amount is also going to be charged. Generally in Maharashtra, the constant amount is nearly 90 to 100 rupees. Okay, even if you use 0 kilowatt of energy or 0 units of electricity bills, even that you have to pay that minimum amount. Okay, that is the constant amount which is used or charged to the consumer. Now this constant amount is depends upon the cost which is required to provide the connection. Okay, because even if the you doesn't use any electricity, any 0 units of electricity, there will be some cost which is related to the energy. The energy must be delivered at your house. Okay, it will require some cost, right? So, or that particular cost will be considered as a constant amount. Okay, so based upon that, there will be a numerical uh, that we are going to see, one numerical related to the tariff method and one numerical related to the load duration curve, or we can say the load curve. Okay, these numerical we already covered, but I will explain another time. The first numerical that we are going to see, that is regarding the tariff method, electricity tariff method. In your MSc, the numerical based upon these 2 points are going to be there. The first one, that is based upon load curve and load duration curve, and also the calculation of different factors, those diversity factors, load factors, capacity factor, etc. And the another point on this particular tariff method, there will be a numerical. So only 2 points having the numerical. So that we are going to cover today. So the first problem we are going to see, that is the energy consumption of a consumer. Energy consumption of a consumer. 1 minute. Okay. the energy consumption of the consumer per month is 2300 kilowatt hour. Kilowatt hour also we call it as a 1 unit. The maximum demand is 12 kilowatt. Using the Hopkinson demand rate as given below, find first monthly bill of the consumer and the unit energy cost. That is your first we have to determine. Then second, the lowest possible bill for a month of 30 days and unit energy cost for a given energy consumption. Okay. So by using the given Hopkinson particular charges, we have to consider or we have to calculate this particular monthly bill for the consumer and also the unit energy cost and lowest possible monthly bill for the for that particular customer. Okay, so demand rates are given for 0 to 5 kilowatt. The rate is 200 rupees per kilowatt. When 6 to 10 kilowatt, the rate will be extended or increased up to 150 kilowatt, sorry, decreases up to 150 kilowatt, 150 rupees per kilowatt. When the demand is between 11 to 15 kilowatt, the rate will be again decreased to 120 rupees per kilowatt. That is the demand rate. Okay, and the energy rate which is given here. Now this demand rate means it is related to the maximum demand, right? Okay, if the maximum demand is between 0 to 5 kilowatts, the rate will be for that maximum demand is 200 rupees per kilowatt. When the maximum demand is in between 6 to 10 kilowatts, in that case, the rate will be 150 rupees per kilowatt. And if the maximum demand is 11 to 15 kilowatt, in that case, the demand rate or that rate will be 120 rupees per kilowatt for the maximum demand. This is the maximum demand rate. Now, energy rates, whatever the total energy consumed by the customer, the rate has been given here. So, for first 100 units or first kilowatt hour, the rate will be 2 rupees per unit. Okay, we can also call this kilowatt hour as a 1 unit of electricity. So, for first 100 units, the rate will be 2 rupees. For next 500 units, after 100 means from 200, 101 units to the 600 units, the rate will be 1.5 rupees, and next 2000 units, the rate will be again decreased to 1 rupees per unit. And also if this use is excessive, it is over 200 units, then the rate will be decreases to 0.8 rupees per unit. Okay, so these are the energy rates. These are related to the consumption. Okay, whatever the amount of energy consumed by the customer, and these are related to the maximum demand. Okay, so based upon this information, we have to calculate the monthly bill of the consumer and unit energy cost. Okay, and the second we have to calculate the lowest possible bill for month of 30 days and unit energy cost for the given energy consumption. Okay, so by using the Hopkinson charges or the Hopkinson charge method or the tariff method, we have to calculate this one. So first of all, what is the equation of Hopkinson demand rate or the Hopkinson or two-part tariff method? That is the Z total energy cost. Okay, it is equal to A plus By, where A is known as the rate per kilowatt of maximum demand plus B into Y. Okay, here we have to write down X, right? Because it is A is the rate per kilowatt of maximum demand and X means the maximum demand. Okay, plus By. B means energy rate per kilowatt hour or the energy rate per unit into total units consumed by the consumer. Okay, so simply we have to use this equation where Z is equal to AX plus BY. Okay, where A is related to the maximum demand, AX is first term, and the second term is related to the whatever the total energy consumed by that particular customer. Now, from the given, you already know the maximum demand of the customer is 12 kilowatt. Okay, now from this here, the maximum demand is 12 kilowatt means value of X is 12. So based upon this maximum demand, we have to consider or we have to choose the demand rate, right? So here demand rate is given. So from here you can see this 12 kilowatt is lies between 11 to 15, and for that the demand rate is 120 per kilowatt. So we have to multiply by 120. Okay, did you understand? So first of all, find out the maximum demand. It is 12 kilowatt. Now the demand rates, the range are given here. Okay, so range that 12 kilowatt is lies between 11 to 15 kilowatt. So for from this particular range, we have to consider the rate. So it will be the 120 rupees per kilowatt, and the total maximum demand is the 12. So 12 into 120 rupees. That is your regarding to maximum demand costing. Now plus second, that is the total energy consumed, that is the Y, and it is again given that the energy consumption of the consumer per month is 2300 kilowatt hour. So the total energy, the value of Y is 2300, okay, into now the rate for this particular equation. Now this is important, okay, whenever we considering the rate of that particular energy or electricity, we have to consider or we have to use this particular given energy rate. You can see here these are the energy rates which are given for the consumption. So we have to consider those rates whenever we considering the or whenever we calculate the energy rates. Now here, so here you can see the total rate. We have to divide this 2300 into the different parts. So first of all, for first 100 units, the rupees 2 rupees per unit will be charged. So we have to split up that this one. So for first 100 units, the rate will be 2 rupees. Okay. Now remaining, then second up to 5 or next 500 units, the rate will be 1.5. So we have to divide this total 2300 or whatever the consumption, total unit consumed by the consumer, into this given rate slab. Okay. So for 500, next 500, here 500, the rates will be 1.5 rupees per unit. Okay. So total units we covered here, that is the 100 plus 500. So 600 units are already covered. Now next remaining units. Now 600 2300 2300 minus 600, the remaining units are 1700. These are the units are remain. Now for next 200 units, even if these units are up to 200, the rate will be 1 rupees per unit. Okay, so here the rate will be 1 rupees. Okay, so you cannot directly use this 2300 and multiply by one particular rate. So you have to divide this 2300 into the given energy rates or into the given ranges. For first 100 units, the rate will be 2 rupees. For next 500 units, rate will be 1.5 rupees. For next 2000 units, rate will be 1 rupees. Even if there the total units remain it up to 200, the rate will be only 1 rupees per unit. Okay, if the remaining units are, consider the remaining units are 2300. Okay, so in that case again, for 200 rupees, for first 200 units, the rate will be 1 rupees, and remaining 300 units, the rate will be 0.8 rupees. Okay, so that's how you have to split up this one. So here 2300, those are the total units consumed. Now first for first 100 units, the rate will be 2 rupees. For next 500 units, rate will be 1.5 rupees, and remaining 1700 units, rate will be 1 rupees. So we have to just multiply this one, just multiply it, okay, and find out the total value. So 100 into 2, 200 plus 500 into 1.5, that is 750 rupees, plus 1700 into 1, that is the 1700. Okay, the total is equal to 0, 5, right? Then 17, 16, 1 will be the extra, 112. So 2650, that is the total rupees which are required to to calculate the, or these are the total cost which is related to the consumption of the electricity. Now again, similar thing we have to consider for the demand rates also, because here that the previous one we directly use these particular ranges, but here also for first 5 units the rate will be 200 rupees, for next 5 units rate will be 150, and for next one rate will be 120. So similarly this one will be the wrong, we have to again use these demand rate ranges. Okay, so these ranges you can use. If only one cost or only one rate is given, then you have to multiply by that particular rate. If the range of the rates are given, then you have to use these ranges. So similar to this one, the total maximum demand is the 12 kilowatt. We have to again split up into the 3 because the first 5, next 5, and third remaining is the 2. So again, the respective rates we have to apply there. Okay, so first 5 200 rupees is the rate. For next 5 kilowatts, 150 rupees is the rate. And for remaining 2 kilowatts or the 2 units, the rate will be 120. Okay, so we have to multiply this one, 5 into 200 plus 5 into 150 in plus 2 into 120. So total will be your 1990. That is your total energy cost related to the maximum demand. Similarly, next, for the consumption also we have to carry out this particularly. We have to split up that total units into the different rates or the different particularly. Just a minute. Into the different parts or the different ranges. Okay. Now we have to add up this 1990 plus this 2650. Okay. 2650. So total energy cost will be 4640 rupees. That is your total amount. Now just concentrate on this given area, given rates. Okay, if only one rate is given, you have to multiply by that particular rate to the total energy consumption. If the ranges are given, you have to use the ranges. Okay, so it is depends upon the given methods or the given data, which type of demand rates you have to consider. You have to consider a different demand rate or the same demand rate. So don't forget this one. It is depends upon the given information. If demand rates are given in the this particular type in the ranges, you have to use these range different rates for the different ranges. If it is only one demand rate is given or in only one rate is given, in that case you have to consider the only one rate. Now this is the total annual or the monthly bill of the consumer, that is the 4640 rupees. Now we have to calculate the energy cost or unit energy cost per unit. So total units consumed by that customer is 2300 kilowatt hour. Okay, so the energy cost per unit, or we can say the cost per unit, is equal to total bill, that is total cost 4640 divided by total energy consumed by that particular customer or the consumer, 2300. Whenever you divide this one, 00 gets cancelled, you can divide it, and after that the final equation or the final rate we got is 2.0 rupees per unit. That is the rate. Okay, so that is the average unit energy cost or given average energy cost given uh, uh, to that particular consumer. Okay, so this is the first we calculated, that is the monthly bill of the consumer and unit energy cost. Now here they ask to use the Hopkinson charges method or the tariff method. In many numericals are there where we have to use the different method. Okay, that method will be mentioned in your numerical. Okay, similar numericals are there in your ISC component in your assignment. Solve those numericals. Most of the questions for the MSc will be came in from that particular assignment. Okay, so prepare those numericals. Such type of numericals will be there in your MSc and also in your final end semester examination. Now next one is, just I will clear this one. The next second, we have to find out the lowest possible bill for a month of 30 days and unit energy cost for a given energy consumption. Okay, now that we first of all find out the monthly bill, actual monthly bill. Now we have to find out the lowest possible monthly bill for that particular customer. Okay, now we know the lowest bill occurs when the demand is maximum. Okay, the lowest bill occurs when the demand is maximum, which is only possible at a 100% load. When we apply all the devices, when we connected all the devices at the same time, then in that case there will be a maximum load will be there or maximum demand will be there, and the bill related to that demand, it will be the lowest bill. Okay, so first of all we have to calculate the average load per hour, or we can say the general average load or the general maximum load. For that, we can write down the average load is equal to 3 total energy consumption divided by 30 days into 24 hours. Okay, so we are going to find out the average load. Okay, the total energy divided by total hours. Okay, so that will give you the average load or the maximum load on from that particular consumer. So it will be equal to 3.2 kilowatts. That is the maximum average load we can say. Now for the 3.2, we already know the charges will be it will lie between 0 to 5 kilowatts, right? So the charges will be, we have to apply these 200 rupees charges. Now the total maximum load charges will be, or first that AX, the first particular term, it will be 3.2 kilowatt multiplied by 200 is equal to 640 rupees. That is the first term you find out. Now the next one is to find out the energy consumed by that particular customer. Okay, so the energy consumption, we know the energy consumption is the same 2300 kilowatt hour, and the total energy rate related to the second term will be remain same. That is that range will be remain same because the ranges will be the same and the consumption is again same. So the next second term will be the same, that is the rupees 3290, that will be the same. Okay, sorry, it is 2650, not 32, 2650. That is the second term. So we have to just add up this one to find out the minimum or the lowest possible lowest possible bill for that particular consumer. That is the 640 plus 2650. That is again 3290 rupees. And also we can find out the unit energy cost for that particular lowest possible bill. Okay, so that's how you can calculate these particular terms. It is totally depends upon the given methods or the given information. Okay, so here they particularly ask to use Hopkinson energy tariff method. In many application or in many numericals, they will ask you to use the different methods. Okay, sometimes they ask to use Doherty rate. In that case, they will give you all the rates. Okay, so this one is the maximum demand rate. It will maximum demand rate, also the energy rate, and also the constant amount that should be the charge. So in that case, you have to add this constant amount. Okay. So whenever they ask to use Doherty rate or three-part tariff, we have to use this particular equation. Okay. If they use, if they ask to use this Hopkinson demand rate or the two-part tariff method, in that case only we have to consider the maximum demand and energy consumption. We doesn't consider any constant amount. We are not going to add any constant amount. Okay. So keep in mind that if they ask to use Hopkinson method, you have to use this particular equation. Only two terms are there. If they ask to use Doherty rate or three-part tariff, we have to add this constant amount at last. Okay, this constant amount also given by that particular in that particular numerical. Similarly, they will ask you to find out the total energy cost by using block meter rate also. In that case, in this particular tariff method, we are going to only use the energy consumed by that particular customer. Now, the rates for the energy consumption are the different one, okay, which is given in this Hopkinson method also. Means for first 100 rupees, sorry, for first 100 units, it will be 2 rupees. Then next 200 units, rate will be 1.5 rupees. So likewise, they will give you the rates for different ranges. Okay, and just you have to add those rates. There will be no any term related to the maximum demand in block meter. So these equations are most important. Whenever you going to solve those numericals, those equations are very important. Make sure you understand those equations, which type of methods they will ask. Just use those equations, and by using those equations, you can calculate the total energy cost. Okay, so it will be the easy one. Just use those equations. Equations are most important. Okay, so that is regarding the tariff method, how to calculate the average cost and other costs or the monthly bill of the consumer. Now this is one type of example. Okay, there will be a many type of examples are available in your textbook. Just refer the textbook or the reference book, or any particularly you can refer the power plant engineering by Numpun one. Okay, in that particular book there are multiple numericals has been solved. Okay, just refer those books. Also solve the numericals which are given in your ISC or assignment. Okay, those type of numericals will be there in mid semester examination, which are present